Hi guys, today we will be discussing a new rule for evaluating limits, that is LHospital rule. So let's say we have to evaluate limit at some point a fx over gx, and this a can be any real number or positive infinity or negative infinity. Okay, so these are the values of a which a can have, and this limit x approaches to a fx exists, and limit x approaches to a g of gx also exists, but the result of this overall limit comes as 0 by 0 or positive or negative infinity over positive or negative infinity. So when we evaluate the limit and our answer comes like this, 0 by 0 or plus minus infinity over plus minus infinity, then in that case we can solve the limit or evaluate the limit by the LHospital rule. Okay, so let's first define what is LHospital rule. So this limit fx over gx is our consideration. So using the LHospital rule, we can write this limit x approaches to a fx over gx as limit at x approaches to a f prime x over g prime x, or you can say f dash x over g dash x. And what are f dash x over or g dash x? They are nothing but the derivative of fx and gx respectively. Now what is derivative? This we'll see in the next section, but for now you just remember that f prime x or f dash x is derivative of fx, and similarly g prime x or g dash x is derivative of gx. Now how we will define derivative? The derivative is the rate of change of that function with respect to the input parameter. That is, f prime x or f dash x is the rate of change of f of x with respect to x. Just remember this definition for now. Okay. So the rule is limit x approaches to a fx over gx, and if it comes to either 0 by 0 or plus minus infinity over plus minus infinity, then we can evaluate this as limit x approaches to a f dash x over g dash x. That is, we find the derivative of the numerator as well as of the denominator function. And if it still comes as 0 by 0 or plus minus infinity over plus minus infinity, then we can again find the derivative similarly. So for the sake of simplicity, let's stick to single derivative. So this is the LHospital rule that I have just introduced to you guys. Okay. So let's look at an example to make it a little bit more clear. So let's say this is we have a function limit x approaches to 2 x cube minus 4 x square plus 4x over x square minus 4. So this is our question, and we have to evaluate limit x approaches to 2. So now let's first put the limits in this numerator function as well as the denominator function. Because both are the polynomial functions and we can directly put in the limits, and we observe that this is 8 minus 4 times, that is 16, 4 times 2 4, that is 16 plus 8, that is 8 minus 16 plus 8, so this is 0. Now in the denominator, 2 square, which is 4, minus 4, this again comes as 0. So we see that this whole is coming as 0 by 0. Okay, so let's first approach this using the factorization method by making factors of both numerator and denominator. So let's factorize these both. So we see that if we put x equal to 2 in the numerator, this polynomial becomes 0. So this means that x minus 2 is a factor of this polynomial. So we can write it as x minus 2, as x equal to 2 is a root of this polynomial. So x minus 2 is a factor of this polynomial. And if we divide this whole polynomial by x minus 2, we will be left with x square minus 2x. So this polynomial after factorization could be written like this. And the denominator could be written as x minus 2 into x plus 2 by the identity x square minus y square. So this will be limit x approaches to 2. Also this x square minus 2x can be split into factors of x. So this can be written as x into x minus 2. And this is x minus 2 multiplied by x plus 2. So now if you look at this, here x is approaching to 2 and exactly not equal to 2. So we can cancel these factors from numerator and denominator since x is not equal to 2. If it had been 2, this would be 0 by 0, right? So we cannot put x equal to 2 here. Since x is approaching to 2, we can easily cancel out these terms from the numerator and the denominator. So this whole thing will now become limit x approaches to 2, x multiplied by x minus 2 over x plus 2. So when we put the limits, this will become as 2 multiplied by 2 minus 2, which is 0 over 4. So the answer is 0. So but we have done this with the help of factorization. Okay. So now let's try to use the LHospital rule here. So let's recapitulate the LHospital rule. So if we put x equal to 2 in this, we get 0 by 0 from here. So which is an indeterminate form. And this is our base condition for the LHospital rule. So and we can apply now LHospital rule here, right? So let's try to implement the LHospital rule in this. So let's write the LHospital rule again. If limit x approaches to 0, so let's say a, fx over gx, it is a form of 0 by 0. This is the case in our example. So we can simply write it as limit x approaches to a, f prime x over g prime x. So let's write our example again. Limit x approaches to 2, x cube minus 4x square plus 4x over x square minus 4. So now let's differentiate both the numerator as well as the denominator. So we can write, so differentiation of x raised to the power n is n times x raised to the power n minus 1. So this is the rule of differentiation which we will see later. In the derivative sections of this course, we will see this. So we will be discussing there in more details. So as for now, you just remember the simple rule that derivative of x raised to the power n is nothing but n multiplied by x raised to the power n minus 1. So by this rule, we will be differentiating the numerator as well as the denominator. So x cube differentiation will be 3 times x square minus 4. You can take it out, this 4 as a constant, and derivative according to the rule for x square, this will be 2 times multiplied by x raised to the power 2 minus 1. So that is 1 plus 4 multiplied by derivative of x will be 1. Okay. Similarly, in the denominator, it will be 2x, and differentiation of a constant with respect to x or any other variable is 0. You just need to remember this for now. So the differentiation of this constant, that is 4, will be 0. So this is the differentiation of the numerator and the denominator. So I'll write it more clearly now. This is 3x square minus 8x plus 4 over 2x. So now let's put our limits again. So now our numerator will be 3 times 4 minus 8 times 2 plus 4 over 4. So this is 12 minus 16 plus 4 over 4, and this is 0. And also it's not an indeterminate form, hence this answer is acceptable. So the evaluation of this limit is coming as 0. So if you observe the difference between this approach and the previous approach where we use the factorization method there, so where breaking the polynomial into factors was a time consuming task, and that required some hard work to calculate the limit using this. But if you use the LHospital rule to evaluate the limit, then it can be really fast. You just need to know the basic rules of definition, or sorry, differentiation. So this and you can easily evaluate the limits. So this is a little shorthand technique to evaluate the limit. So let's now take a look at another example on this. So our question is, limit x approaches to a, x raised to the power n minus a raised to the power n over x minus a. Now let's put the limit x approaches to a in this function. It will give us a to the power n minus raised to the power n, which is 0, minus a to the power n, that is 0. So this, and in the denominator also it is coming as 0. So this is form of 0 by 0. So hence we can apply the LHospital rule here, right? So now let's apply that. So let's write the rule again. It's limit x approaches to a, fx over gx if both of these limits are existing for the numerator and the denominator, and our evaluation is of the form this fx over gx, and the evaluation is resulting in indeterminate form when we put the limits. Then we can apply LHospital rule here, and we can say limit x approaches to a, f prime x over g prime x, or f dash x over g dash x, where f prime x is derivative of fx and g prime x is derivative of gx, right? So okay, now let's find derivative of both the numerator and the denominator. So f prime x will be, as discussed in previous example, derivative of x raised to the power n is n times x raised to the power n minus 1, and a is a constant, and hence it will result in 0, as a derivative of a constant is 0, over derivative of x is 1. 1 times, you can say, x raised to the power 1 minus 1, that is 0. So it will be 1 into x to the power 0, which gives us 1 minus 0, as a is again a constant here. So this comes as limit x approaches to a, n times x raised to the power n minus 1. And now we can easily substitute x equal to a in this expression, and this becomes n times a raised to the power n minus 1. Substitute, and since we can substitute x equal to here. So this is very easy way of evaluation of this limit. And contrary to this, if you would have applied the factorization method to evaluate the limit, this limit, then and the numerator has a factor x equal to a, and you could have also cancelled the x minus a term from the numerator and the denominator, but it would have been very tedious to calculate the remaining factors of this polynomial. So it will take a lot of time actually to calculate the end result for this limit, right? But this LHospital rule, this rule enables you to get the result really fast. So I guess it took us less than a minute to get the answer using this rule. So if we know just the same basic rule, some basic rule of derivatives, which you can either like use to evaluate your result or use it to verify your result, right? So guys, this was it for the LHospital rule. Do join me in the next video where we discuss about the sandwich theorem. Thank you.